Okay, but there when the corners are pointing into the graph and the coordinate axes. Okay, so I know that it cuts the y-axis when x equals 0. So putting that in, I got 4 times minus 2 over minus 4, just 2. So 0, 2 is one coordinate, and it cuts the x-axis when y equals 0. So I'm solving x plus 4, x minus 2 over x minus 4 equals 0. When I solve a fraction, yeah, the 0 I'm only interested in the top line being 0. And that's what happened when x is minus 4 and when x is 2. So that's at minus 4 0 and at 2 0. So there's the coordinates of where it crosses the coordinate axes. Part B, I want the equation of the vertical asymptote. So the vertical asymptote is the equation of x. That's not allowed, and I take that from looking at the bottom line, and if I'm divided by 0, I get an invalid, I'm not able to calculate a value at that point. So the vertical asymptote is when x is equal to 4. And part 2, this asymptote is not parallel to coordinate axis, so I got an oblique asymptote here. And if we look, we got a top-heavy fraction. The power is higher on the top than the bottom. So if I expand out the top line, that's x squared plus 2x minus 8 divided by x minus 4. So I need to divide that in. So x into x squared goes x times, multiply it back, x squared minus 4x, subtract 2x minus 4, 6x, 0, bring down the minus 8, x into 6x minus 8 is plus 6, multiply it back, that's 6x minus 24, subtract minus 8 plus 16. So what I've got then, so y is x plus 6 plus 16 over x minus 4, and as x tends to infinity, y is going to tend to the equation x plus 6. So the equation y equals x plus 6 is the oblique asymptote. Part C, I want the coordinates of the stationary points, so I need to differentiate. So I've got f of x out in this format. So that's u over v. So it's a quotient, so I'm after v du dx minus u dv dx over v squared. So u is x plus 2x minus 8, v is x minus 4, so du is 2x plus 2, dv is 1. So f dash of x then is v du minus u dv all over v squared, which is that. Let's expand the top line. That's 2x squared minus 8x plus 2x minus 8. We got minus 8x over minus 4 squared. So stationary points, I want just the coordinates of stationary points. Okay, so stationary points okay with f dash of x equals 0. So I'm solving the top line, tells me when that fraction is 0. X bracket x minus 8 So x equals 0 or x equals 8 is where my stationary points are. So if x equals 0, then f of x is minus 8 over minus 4, which is 2. So 0, 2 is one stationary point, and if x equals 8, then f of x is, what we got, we got 64 plus 16 minus 8 divided by 4. Just calculate that. That's 18. So there's the stationary points, two stationary points. They did ask me about the nature and things. I can reason that out when I come to the shape of the graph. Let's sketch the graph of f on the axes. So let's see what we got. Just build it up. There's my axes, so x and y. So I've got asymptote going through there. I got a vertical asymptote at 4. So the graph can't cross that. I've got an oblique asymptote, y equals x plus 6. So that's a straight line going through 6 and minus 6. It's cutting the y-axis at 0, 2. So it's cutting axis at 0, 2. It's cutting it at minus 4, 0, and at 2, 0. I got a stationary point at 0, 2. Well, the only way that can be a stationary point because the curve got to come through these. So that one's the maximum. I got another stationary point at 8, 18, which is the right of that, and above that, so there's another stationary point there. So the graph, and it tends along this curve, so it's got to do that. Let's go through 2. There's a minimum there. So it's doing that. So there's the shape of the graph, and S is minus 7, 3. So for the first part I want f of s. So what this means is then for this part the domain is minus 7, 3. What is the range? So minus 7, 3 starting there and then ending up here. So as x runs from minus 7 to 3, then the graph is doing that. So I want the range. Well, the highest value is 2, and I don't know the lowest value at the moment. Remember, it's a sketch, so I don't know whether minus 7 is going to give me a lower value than 3 is. So I need to work out f of minus 7, and I need to work out f of 3. So going back into the original equation, so f of minus 7 is minus 7 plus 4 over minus 7 minus 2 over minus 7 minus 4. So that's minus 3 times minus 9 over minus 11. It's a positive, so that's a negative. Up on top is 27 over minus 11. If I put 3 in, I got 3 and 4, 3 minus 2 over 3 minus 4, which is 7 times 1 over minus 1, which is at minus 7. So the lowest of these two values is minus 7. So the range f of s will run from minus 7, because that's the lowest value, up to the highest value, which is at 2. and just check there, those are in square brackets, sorry, for S, so I can actually take those values, so these must be square brackets as well. The second part is f to minus 1 of S, so what that means is I'm going from minus 7, the graph here, up to 3, which is there, and as I'm running minus 7 to 3 on this axis, what values of x am I taking? Well, the minus 7, it's running from there to there, but going up to 3, that's got no effect. So the two extremes here, right, if the range is minus 7 up to 3, the domain is going to go from that value to that value. So I need to solve f of x equal to minus 7. So I'm solving x plus 4, x minus 2 over x minus 4 equals minus 7. So expand that out, top line, x squared plus 2x minus 8 equals minus 7 bracket x minus 4. 8, take it all over, x squared plus 9x, take that over there, minus 36 is what? So that's x plus 12, x minus 3. So x equals 3 or x equals minus 12. So the domain then is running from minus 12 to 3. So f to minus 1 of s is minus 12 to 3, and they are square brackets.